You don't remember being born. You don't remember your first word, or the first time you pulled yourself upright and took a step, or the face that was looking down at you when you did. Those moments happened. They were real. Someone was there, watching, probably crying a little, and you were there too, conscious, present, taking it all in. You just can't get back to any of it. That's not a quirk. That's not a gap in an otherwise functional system. The first 3 to 3.5 years of your life, the most consequential developmental period your brain will ever go through, are almost entirely gone. Not fuzzy, not fragmented, gone. Here's the assumption everyone makes, that babies don't really experience things in a way that counts, that the memories aren't there because nothing was really registering, that it's fine, because what would a 2-year-old even have to remember? That assumption is completely wrong. You were registering everything. You were sorting faces by trustworthiness before you could hold your own head up. You were tracking the emotional temperature of every room you entered. You were learning at a rate you will never match again for the rest of your life. And you were doing all of it while fully, genuinely conscious of the world around you. The experience was there. The processing was there. The memory just isn't. Which, honestly, is one of the stranger facts about being human. Not that we forget things, everyone forgets things, but that the period of our lives that built the most foundational version of who we are is sealed off. Inaccessible. You can't go back and look at it, can't examine it, can't even remember what it felt like to be that small. Psychologists call this infantile amnesia, and it's so consistent, so systematic across every culture and every person that it stopped being a curiosity a long time ago. It became a genuine scientific problem, because something is erasing this, deliberately and completely. The question is what? So let's actually look at what infant consciousness is, because this is where the assumption falls apart completely. Newborns, hours-old newborns, not weeks, not months, already show a measurable preference for their mother's voice over a stranger's. Not because they learned it after birth, because they were listening in the womb, in the final trimester, and they encoded it. They came out with existing preferences. That's not a blank slate. That's a person who already has opinions. By 2 months, infants track faces with enough precision to distinguish emotional expressions. By 4 months, they show something researchers describe as surprise when an object behaves in a way that violates their expectations, which means they had expectations. They built a model of how physical reality works, and they're already testing it. Think about what that means for a moment. There was a version of you that was actively building a theory of the world before you could sit up unassisted. The grief response is the part that gets me every time. Infants separated from their primary caregivers show measurable cortisol spikes, the stress hormone, within minutes. Their heart rate changes. Their behavior changes. They are not confused in some vague, undifferentiated way. They are distressed in a specific, directed, relational way. They know someone is missing. That is not the response of a system that isn't registering experience. That is the response of a conscious being who noticed an absence and cares about it. None of this is fringe. This is mainstream developmental psychology, replicated across decades of research, across cultures, across species. Which makes the amnesia stranger, not less strange. Because you weren't a passive recorder failing to capture footage. You were an active, experiencing, feeling participant in your own life. You had preferences, expectations, relationships, and grief. You were, by any reasonable definition, there. And then, somewhere around age 3, give or take, the door closes. Not gradually, more like a cliff edge you walk off without noticing. Everything before it, gone. Memory is not a recording. This is the part most people get wrong, and it matters enormously for understanding what happened to your early years. When you remember something, your brain isn't playing back a file that was saved at the time of the event. It's reconstructing, actively, in real time, from fragments stored across different regions, stitched together by a structure called the hippocampus. The hippocampus is the brain's memory indexer. It doesn't store the memories itself. It holds the map that tells the rest of the brain where the pieces are and how they fit together. Without it, you can experience things perfectly well. You just can't file them anywhere retrievable. This is why hippocampal damage in adults produces such a specific, strange kind of amnesia. The person is conscious. They're processing. They can hold a conversation, feel emotions, even learn new physical skills. But ask them what happened 20 minutes ago, and there's nothing there. The experience occurred. The indexer just wasn't working. Now picture that indexer in an infant brain. It exists, it's not absent, but it's structurally immature in ways that make long-term autobiographical storage essentially impossible. The lens is working, the processor is running, but there's nowhere for the footage to go. What makes this genuinely strange is that this isn't the whole explanation, because the hippocampus matures gradually, and yet the amnesia doesn't fade gradually, it cuts off hard. Most people's earliest retrievable memory sits somewhere between age 2.5 and 3.5, and below that line, there's almost nothing. Not a few blurry frames, a wall. So the immature hippocampus explains part of the gap, but something else is actively making it worse. Something about the infant brain isn't just failing to save memories, it's disrupting the ones that might otherwise stick. And that something, it turns out, is the very thing that makes infant brains so extraordinary at everything else they do: neurogenesis. That's the thing making it worse, and also the thing making you possible. In the first 2 years of life, your hippocampus is generating new neurons at a rate that will never happen again. Hundreds of thousands of new cells, integrating into existing circuits, forming new connections, rewiring the architecture constantly. This is what makes infant brains so extraordinary at absorbing new information. The hardware is literally expanding in real time, tuned for maximum intake, optimized for learning at a speed that makes adult cognition look like dial-up. But here's the trade-off the infant brain made, apparently without consulting anyone. All that new growth actively disrupts the memories that were just forming. Picture a library. Not a tidy one, a chaotic, expanding one, adding hundreds of new shelves every single day. Books are arriving faster than they can be cataloged. Old filing systems get overwritten by new ones. The books from last Tuesday aren't lost exactly, they're just buried under the reorganization, cross-referenced by a system that no longer exists, in a wing of the library that's been completely rebuilt since then. That's roughly what neurogenesis does to early memory traces. It doesn't erase them cleanly. It buries them under its own expansion. Researchers call this process the disruption of existing memories by the integration of new neurons, neurogenesis-induced forgetting. And the evidence for it is genuinely striking. When scientists artificially suppress neurogenesis in young mice, the mice retain early memories far better than they otherwise would. When they artificially boost neurogenesis in adult mice, adult memories start degrading faster. The mechanism runs in both directions. More growth, more forgetting. If this is the kind of thing that gets you, drop a like, leave a comment. It genuinely helps. Anyway, so the infant brain isn't broken. It made a deliberate architectural choice: speed of learning over continuity of memory. And it made that choice at exactly the moment when learning mattered most. The cost was your first 3 years. The benefit was everything else you know how to do. There's a third layer to this, and it's the one that took researchers longest to take seriously. To remember something as a personal experience, not just as a fact, but as something that happened to you, in a specific place, at a specific time, with a specific emotional texture, you need what psychologists call autobiographical memory. The "I was there and this happened to me" variety. An autobiographical memory, it turns out, requires something the infant brain doesn't yet have. It requires a narrator. Not metaphorically, literally. The ability to organize experience into a coherent personal story, beginning, middle, end, cause, consequence, this happened and then this happened because of that, is built on language. Specifically, it's built on the kind of self-referential language that lets you place yourself inside a sequence of events and say, "This was mine. This was my experience. This belongs to the story of me." Children don't have that scaffolding until somewhere between 2 and 3 years old. And here's where it gets interesting. The data on earliest memories clusters tightly around the point when children acquire narrative speech. Not just words, narrative. The ability to tell a story with a self at the center of it. The cross-cultural evidence is striking. Maori adults in New Zealand, raised in a culture with exceptionally rich oral storytelling traditions and strong emphasis on personal narrative from very early childhood, consistently report earlier first memories than adults from cultures where early childhood storytelling is less elaborated. Same brains, same hippocampi, different scaffolding, and the memories reach back further, which means part of what you lost wasn't just biological, part of it was structural. You didn't yet have the cognitive architecture to file an experience as yours. You were living inside moments you had no framework to claim. You don't remember learning to see, but you can see. You don't remember learning that objects are solid and permanent, but you know it instantly. You don't remember learning to read a face for emotional meaning. but you do it thousands of times a day without thinking. All of that was learned in the years you can't remember. Here's where it stops being just neuroscience. You forgot the experiences. You kept the lessons. The problem is you can't examine lessons you don't know you learned. There are two kinds of memory. Explicit memory is the kind you can access consciously. The birthday party, the conversation, the face. Implicit memory is different. It's the kind that lives in your behavior, your reflexes, your automatic responses to situations before your conscious mind has even finished registering what's happening. Implicit memory doesn't feel like remembering. It feels like just being who you are. And implicit memory has a much longer developmental reach than the hippocampus does. The experiences you had in your first 3 years, the ones with no explicit trace, the ones you cannot retrieve or examine or even know occurred, those experiences trained your implicit system extensively. They set the baseline calibration for questions your nervous system is still answering right now. Is the world generally safe or generally threatening? Are other people reliable? When you reach for comfort, does it arrive? When you're distressed, does someone come? Attachment researchers call these early patterns working models, not memories, models. Internal operating assumptions about how relationships function, built from thousands of repeated interactions in the first years of life, consolidated below the level of conscious access, and then carried forward into every relationship you've had since. You didn't decide on these models. You couldn't have. You didn't have the cognitive architecture to decide anything that abstract. They were installed by experience in a period you can't see, and they've been running quietly in the background ever since. This is the part that sits with me. Not the forgetting itself. The forgetting has good biological reasons, and we've been through them. It's the fact that the forgetting didn't erase the influence. The experiences shaped you and then disappeared, leaving their work behind but taking all the receipts. You are carrying conclusions drawn from evidence you no longer have access to, and you can't audit a conclusion when the evidence is gone. Now let's make this slightly more uncomfortable. Think about the earliest memory you actually have, the one you'd point to if someone asked. Hold it for a second. The image, the feeling, whatever fragment of it remains. Got it? There's a reasonable chance it didn't happen the way you remember it. There's a smaller but non-trivial chance it didn't happen to you at all. This is extremely well documented in memory research, and it's deeply unsettling the first time you really sit with it. Memory isn't just reconstructive in the moment of recall, it's reconstructive at the point of storage too. Every time you retrieve a memory, you're not playing it back unchanged. You're rebuilding it, and in the rebuilding, you introduce small errors, absorb details from other sources, and then resave the altered version as if it were the original. The file overwrites itself each time you open it. For early childhood memories specifically, there's another layer. Researchers call it childhood amnesia offset, the boundary zone around age 2 to 4 where genuine episodic memories and constructed ones sit right next to each other with no reliable way to tell them apart. In this zone, repeated family stories become memories. Photographs become memories. Being told, "Remember when you did that thing at the beach?" enough times becomes a memory, complete with sensory detail your brain filled in from nothing. Elizabeth Loftus, a memory researcher at UC Irvine, spent decades demonstrating how thoroughly false memories can be implanted in adults, not just suggested but fully formed, emotionally resonant, and completely indistinguishable from real ones. For early childhood, the mechanism runs even more freely, because the original encoding was so fragile to begin with. The honest answer is you cannot know which of your earliest memories are genuine and which are reconstructions. Not with any certainty. The brain doesn't tag its own fabrications. It files them all under the same heading, mine, which is a strange thing to sit with. The earliest version of yourself you can access might be a collaborative fiction, assembled by you, your family, and a handful of photographs. And it feels completely real. It feels real because, to your brain, it is. Not everyone's amnesia boundary sits in the same place. This is one of the more quietly strange findings in this whole area of research. The average earliest memory lands somewhere around age 3 to 3.5. But some people have clear, apparently genuine memories from age 2. Others have nothing before 5. The gap between those two extremes is enormous when you consider how much development is happening in that window, and the factors that shift the boundary are not what you'd expect. Culture moves it. Measurably, consistently, and by a significant margin. Studies comparing adults from East Asian cultures with adults from Western European and North American cultures find that East Asian adults tend to report later first memories, on average by about 6 months. The leading explanation connects to the same narrative scaffolding we talked about earlier. Cultures that emphasize individual autobiographical storytelling from early childhood produce adults whose memories reach back further. Collective-oriented cultures, where the emphasis is less on the personal story and more on the shared one, show the opposite pattern. Same biology, different memory horizon. Gender shifts it too, though modestly. Women on average report slightly earlier first memories than men, and their earliest memories tend to carry more emotional detail. The mechanism isn't fully understood, but it likely connects to differences in how early emotional conversations happen. Girls are, on average, talked to about feelings earlier and more elaborately than boys, which may give emotional experiences a richer verbal scaffold to attach to. And then there's the amygdala. This is where it gets genuinely dark. The amygdala, the brain's threat detection and emotional intensity system, matures on a faster developmental timeline than the hippocampus, which means it's online, tagging experiences as significant long before the hippocampal indexing system can reliably consolidate them into retrievable autobiographical memory. Under normal circumstances, this mismatch mostly just contributes to the amnesia, but under conditions of early chronic stress or trauma, the amygdala's heightened activation can push certain experiences through the consolidation barrier that most early memories never clear. Early trauma can produce earlier memories. The stress system matures faster than the narrative system, and it does so for reasons that have nothing to do with your benefit and everything to do with survival. The brain prioritizes the threat. It always does. So bring it back to the beginning. You don't remember being born. You don't remember your first word, or the first time you pulled yourself upright and took a step, or the face that was looking down at you when you did. We started there, and it felt like a loss, like something was taken, like the most consequential chapter of your life was written in disappearing ink. But here's what that chapter actually contains. It contains the moment your visual cortex learned to resolve a face from a blur of light and shadow, a process so complex that no computer system has fully replicated it, and you did it in the first weeks of life without any instruction. It contains the moment you understood, somewhere deep in your developing nervous system, that objects continue to exist when you can't see them, a conceptual leap so fundamental that it restructures how you experience reality, and you made it before you could walk. It contains the first time you reached for someone and they came, and the architecture of that moment, whether they came, how quickly, how consistently, is still inside you, still shaping how you reach for people now, decades later, in ways you almost certainly haven't traced back to their source. The memories are gone. What they built is not. You are sitting right now with a nervous system calibrated by experiences you cannot access, running on conclusions drawn from evidence you no longer have, shaped by a version of yourself so early and so unformed that it didn't yet have the language to say, I. That version of you was real, conscious, present. Feeling everything with the full intensity of a being for whom everything is new and nothing is filtered yet. They mattered those years. They mattered more than almost any that followed. The neuroscience is unambiguous on this. The density of learning, the speed of structural change, the depth of the impressions left. No other period comes close. You just weren't allowed to keep the receipts. And maybe that's the strangest thing of all. Not that you forgot, but that the forgetting was the price of everything else. The cost of learning that fast, that early, was continuity. You traded your memories for your mind. You don't remember any of it. It's all still there.